Howdy, my name's Jeff Hilland. I'm president of the DMTF, but largely here I'm speaking on behalf of HPE. I work in the office of the CTO, where I'm a distinguished technologist working on various standards, management initiatives, and other items. Just to let you know, a quick disclaimer, you'll see this a lot from anything from the DMTF, where it's a subject to work in progress type snapshot is what you're seeing. I'll go over a couple of things that aren't on the slides today as well that may or may not be released, just to give you a heads up of what's coming. And so all of this information is subject to change without notice. Sometimes it will change profoundly depending on what state it's in when we're published it. What I plan on going over today, and feel free to ask questions anytime. If you've got anything, as you'll see, I've been doing Redfish for quite a long time. So any questions you have at any time, feel free to stop me. If I'm not going to cover it in a few upcoming agenda, I'll be glad to go over it. Your time is valuable and you're here and you're present, so let's take advantage of that. I'll go a quick background of the DMTF, who we are, what we do, and then get into Redfish, where it started, where it came from, and then go into local storage. What I'm really presenting here is the Redfish data model, not the Swordfish one. They're not mutually exclusive. The Redfish one is kind of a subset of the Swordfish one and was invented long before Swordfish was adapted, and you'll actually see it covered in the Swordfish spec. So I would call it a proper subset. But there have been some changes as we worked with SNIA. We came up with some ideas for how to do things, and NVMe was a big change to some of the models, and you'll see some of that later as well. I'll go over security in the fabric model, and then I'll talk about this thing called Redfish device enablement and why that becomes important, and then what does it all look like in all its gory details right at the very end. So the DMTF has been around, I guess, close to 30 years now, maybe more. I should know that by heart by now, but I don't. It originally was the Desktop Management Task Force and started with this DMI and some other specifications, and then some early precursors to IPMI came out of it. So it's been around quite a while. Focusing on management has really been its focus, and that's all kinds of management, everything from cloud to servers, system storage, networking, inside the box, outside the box. It really is all about management. So it's led by innovative, industry-leading companies, really a who's who nowadays. Not everybody's a board member. We've got a bunch of leadership in different levels as well. You can go on the website and see who all is participating. But really, what we're trying to do is drive management standards across the ecosystem. And to that effort, it's important for us to be a nationally and internationally recognized standards body. So we have a fast path into ISO to get our specs ISO recognized. That helps in international cooperation a lot, government contracts, things like that. So it's a benefit both to the standards body and to those people that are implementing our specifications. And then how we do it, well, we're an open standards body. Anybody can join at any membership level, and we're one of the more cost-effective organizations out there. We do have some forums and things like that that cost additional membership, but by and large, it's pretty lightweight and pretty inexpensive. Certainly you will recoup your development costs if you participate in a very short order of time, considering what the personnel would be required to do the same level of development. So amortizing that cost across the industry is beneficial to any organization that joins a standards body. But we also have the ability to do open source and open standards, and that means we can do open source in the public. We can do it in private and then make it public. We can do it in the public. We can, we've got a bunch of different flexible models for making sure that open source and open standards are developed at the same time. Really, it's an open community effort, and so you'll hear that I've kind of switched my nomenclature when giving a lot of talks nowadays to just talk about open communities, because it really doesn't matter if it's open source or open standards. A lot of people are doing both at the same time. Swordfish being an example of that too. The DMTF board member companies, we've got a bunch of people that are really dedicated to carrying the state of the art of manageability forward. One of our newest board members is Verizon, so it's really nice to have a customer's perspective in the standards bodies. A lot of us, it tends to be inside baseball, right? You get your suppliers and your consumers in there. And but when it comes to things like Redfish and Swordfish, there's an end user out there. You're aiming at a DevOps mindset. And so having somebody that's truly investing in what you're implementing in a multi-vendor way is been beneficial to the development of the standards. One standards body doesn't cover it all. We've got a bunch of different alliances with different standards bodies and efforts out there, and we've kind of tailored them around, this is a fairly new diagram, to represent what bodies we're communicating with respect to different standards. So Redfish by far takes up about a third of the DMTF public awareness, and you'll see that's true with our alliance partners as well. It's everybody from ASHRAE when it comes to power and cooling. There's the broadband forum when it comes to telco, CXL when it comes to fabric, Gen Z before that, the Green Grid, Open Compute. Open Compute's an interesting body to have a relationship with, because whereas we tend to be rather descriptive, you'll see a bunch of standards bodies go ahead and make their standard, but it's up to you to actually implement it. We do have a registry now that you can find out who's implementing what DMTF standards, but our standards don't tend to be proscriptive, and it's a set of terminology John Leung at Intel uses. He's our VP of Alliances. And I like that, because what OCP can go in there and do is say, okay, here you've got a suite of specifications. Everything is optional. We're going to make you have these certain features and functions and properties required. And so that proscriptive approach has been very beneficial as an alliance partner goes. Open Fabric Alliance, we're working with them. I think there will be a discussion on OFMF, Open Fabric Management Framework, later. PICMIG, OpenStack, SNIA, of course, Telemanagement Forum, UEFI are all pretty important to Redfish. But Redfish isn't everything, right? We've got some cloud efforts. We've got the old SIM stuff. SPDM, the Security Protocol and Data Model, I'll go into in a little bit. That's being rather widely adopted as a way to extend your root of trust inside the platform, and now it's moving outside the platform. And then this thing called MCTP, PLDM. Has anybody ever heard of that? MCTP, PLDM, raise your hand. Yes, no, okay, you care. So I'll talk a little bit about that in detail in a minute. We've also got some academic alliance partners. That's an interesting thing to have. People doing research and or extensions and or just trying to get a feel for what's going on in the industry. As an academic, you have a completely different time frame than someone in industry. We sit in a standards body or start an effort and we want something out in months, and these people tend to look a little long term. Or grad students who are looking to just fill out a requirement to getting a degree. So it's kind of interesting, the perspective that they'll bring. It's not one that we could get in any other way. So DMTF does a lot more than just Redfish, okay? SM BIOS is probably something you may or may not be aware of. It's been in every x86 machine built for the last 20 years, so it's literally in billions of machines out there. We have this thing called PMCI, Platform Management Communication Interface, or sorry, Infrastructure. We changed it. It's inside the box using these signals that exist, and some of them are laid down, things like I2C and I3C, as well as PCI and CXL, in order to gather all that information. There's a whole lot of magic that happens when a system boots up. Usually a management processor wakes up first before the CPU memory plex wakes up, kind of feels everything out, and that's getting more and more important when you're trying to build a secure infrastructure. So knowing what's out there, making sure it's valid, making sure it is who it says it is, and then gathering all this data that's needed to expose what that is, both to SM BIOS and to the infrastructure management before you ever let go of it and wake up that processor, is becoming more and more relevant, not less and less. And that's what the PMCI workgroup does. There's this thing called MCTP and another thing called PLDM, and those are the protocols that go on inside the box to figure out what all these devices are and provide different features and functions. There's monitoring and control, there's sensor data, there's FRU data, there's this thing called NCSI that can go over Ethernet, there's firmware update. You can do firmware update inside the box without ever having to involve the host CPU. And so if you're building something where you really don't trust that CPU, that's important. And then SPDM runs over that as well. So a couple of things about PMCI. There's a new version of the FRU spec, if anybody cares about that. The old IPMI FRU spec has been great. It's worked well for us, but there's all these extended data records on it, and you'll see as many as 32 extended data records now on a device. And so we're working with industry partners to try and figure out a better way of representing that FRU. That was great when everything was bitwise. But we found ourselves taking a JSON file, converting it into a bitmap, then taking that bitmap and converting it back into a JSON or XML file. And that's just stupid because the flash parts are big enough to hold it all. So why are we doing that? Especially when it'll take 32 IOs per device pre-boot just to wake your system up. So we're looking at figuring all that out. And so if you play in that space, go look at that work in progress that's out there and let us know what you think, because that's out there for review right now. The other thing that's out there is MCTP 2.0. If you play in the 1.0 space where everything's 59 bytes at a time per record, it's hard to do a firmware update 59 bytes at a time over I2C. Especially if now you're running a security protocol and data model over it, which I'll get to in a minute. That could be encrypted. So now I've got extra overhead. So I'm talking, 50, 40 bytes at a time to do all this infrastructure. Not really workable, especially when there's only 250-ish endpoints inside the system. So MCTP 1.0 is showing its age. We've got a work in progress out now for MCTP 2.0 features and functions and all the rest. So again, if that's a part that you play in, if that's a space you play in, let us know, because we hope to get that churning pretty fast. We've made some major decisions, kind of figured out the features and functions what we'd like in there, and we're looking for feedback in the industry. We will be reaching out to all the alliance partners, me included, to see, are we on the right track or not? Because MCTP is the kind of thing that's in silicon, and it doesn't turn very much, doesn't turn very often, and so it's a major leap to get everybody synced up to get to speak that protocol and those improvements. So please take a look at that. PMCI Tools Task Force. So there's a bunch of tools that have never been available before because you're down there at the wire bit for bit inside the box. How do you inject packets in there? How do you test it? A bunch of people have had a bunch of private tools. We're looking at consolidating all of that and making it public. SPDM work group, it's now a work group. It used to be under PMCI. That's the Security Protocol and Data Model. That really, we started out with the USB authentication model just because it was, proven, and it's really not that different from TLS, honestly. It provides some functions that TLS doesn't, and those are really important inside the box. So if you walk away with nothing else about SPDM, it's really that way of providing authentication, attestation, and encrypted key exchange when the system is booting. The first time a management processor, a host processor, anything else out there can go off and authenticate that device, validate who it is, make sure it's talking to who it is at the firmware levels it's supposed to be, and start encrypting the traffic and data communication between them in a key exchange that's very similar to the way TLS works. It does some things that TLS doesn't, like measurement. You don't really, when you're talking to your bank, you don't care about the firmware or software or whatever's running at the other end. When you're starting a box, you're reaching out a root of trust, you really do care about that firmware footprint, measurement, encryption, signing, all the rest. And so there's some things in SPDM that you won't find in other protocols, which is why we see it being leveraged by PCIe, CXL, Open Compute, JEDEC, HDBaseT. HDBaseT is an interesting organization. They do video, conference video like this one. So they do that kind of equipment. So, it's really kind of, the industry really only needs one protocol like this. You don't need a whole bunch of them. So there's a lot of research going on to make sure it's, as secure as it says it is, and all the rest. So, and of course, we've got mappings for MCTP as well as encrypting MCTP, because the goal of this was not only to attest to the components inside the system, but to ensure that management traffic is encrypted and secure in flight. So, you'll hear that a lot, right? Data in flight. I don't care if it's management data or user data, it needs to be encrypted and secured. And so that's what SPDM does, amongst other things. And then there's a security code task force that's looking, it's about one rev back all the time. So when 1.2 is released, they do a 1.2 code base out there. It's a sample implementation. We use air quotes on that. We're not guaranteeing it's good enough for product, but there are people out there certainly have interest in putting that into their product code footprint. So Please take a look at that if that's where you're interested in. And of course, DMTF also does the Common Information Model. All the WebM stuff is still around. It's still in systems. WMI is still based on it. So there's a lot of continuity that's needed there. You know, SMIS has finally moved off of it and used the last version, but that's kind of where our relationship with SNIA started, was in SMIS and its use of the Common Information Model. That's still being maintained by the SIM Forum. It used to be about, I don't know, 8 or 9 orgs inside the DMTF, and as the need for representing new data structures has kind of dwindled, we're not doing 3 and 4 releases a year now, we're doing about 1. So with that, on to Redfish. So what is Redfish? Redfish is an industry standard software-defined management infrastructure for converged hybrid IT as defined by DMTF. That's a mouthful. We started this about, I don't know, 10, 12 years ago inside of HPE, trying to figure out what the next generation infrastructure looked like. If you've got some time later, I'd be glad to go over exactly how we thought of it and where it came from. We gathered a bunch of people, of like-minded folks together, and we took the standard to the DMTF. RESTful interfaces were the interface du jour, and JSON was where everyone was going instead of XML. Really, we say it's RESTful, but what it really is a separated transport from the data model as far as a design goes, because transports come and go. Your data modeling language is going to come and go. Think how your browser works, right? XML is a plugin, JSON's a plugin. If you're transporting the data, encoding it and decoding it is a cost of overhead. And so while we defined it in JSON, it can really be represented in almost anything. The reason we defined it in JSON was we needed to pick one because we were putting it into firmware on BMCs. So we wanted everyone to at least use one thing, and so we said JSON. And RESTful, well, there's 2 kinds of interfaces out there. There's RPC and RESTful, and you can map RESTful to RPC, but it's really hard to map RPC to RESTful. And so we picked RESTful, and so that's the way it's represented. So it's schema-backed but human-readable because we figured DevOps folks didn't read manuals. And so you should be able to kind of look at a payload, and for 90% of the functions, you should be able to just look at it and from the property name kind of intuit how it works. Now that was the goal for 1.0, and obviously as you grow your scope, that gets a little tougher to do, especially in more complex environments. But still at its base, it really is meant to be, you know, human-readable, but also fit for machines. Extensible, secure, and interoperable. We've got the Redfish Interoperability Forum and Code Task Force that goes in there and looks at creating tools that ensure it's interoperable, but that's also where OCP comes in. And I'll go into how we work with them in just a second. It's actually published as an ISO spec, both schema and the protocol spec itself. We're continually updating that as we go through the different Redfish versions. You can always get the latest stuff at redfish.dmtf.org though. The initial release was in 2015. We were looking at replacing IPMI over LAN. So we started with a big scope, figuring out, all right, we wanted to do everything in the infrastructure, but you can't boil the ocean in the first release. So we tied the number of features and functions down to just meet comp with IPMI 2.0, and we published that in 2015. But since then, it's grown over time, and really, we did have the vision all along where you could represent any kind of infrastructure in it, whether it was, you know, rack mount blades, HPC, racks, whatever folks came up in the future. The way it was developed with a sandbox approach where, you know, anybody could own their URI and everything under it, really helped it grow, and that's why we have so many alliance partners, because we've had alliance partners take the spec, and SNIA being one of them, but we really helped SNIA a lot. The Broadband Forum was the interesting one because they'd had this thing called OPAF, Open Process Automation Foundation, that created this open process automation specification, and they took what we did and we included instructions on how to extend Redfish, and they extended it to include operating systems and hypervisors and workloads and all of the rest. So if you've got interest in that space, that was kind of cool. So, you know, we hit the right design at the right time, and I think that had a lot to do with Redfish's success. So since then, you know, the current releases address a lot of IT infrastructure, and we worked with a lot of alliance partners to make sure that's true. SNIA, ASHRAE, OCP, Gen Z, and the rest. But because we're doing it in the DMTF, we had all this inside baseball, all the PMCI and MCTP specs, that, all that infrastructure inside the box. We wanted that to work well with representing that data outside the box. So all the PMCI specs kind of have a mirror to get that data outside the box through Redfish. And then the current releases, there's profiles, test tools, integrations, and a lot more. We integrate with different components and different infrastructures. You can go out on the DMTF website and find out what all those are. It's a list that's continually growing over time. So the timeline, I've modified this spec a lot, this slide a lot over time. Really, there's some big milestones. 2014 was when we formed SPDM it's a mouthful, formed in the DMTF. That's now called the Redfish Forum. And then a year later, that original spec that we took in, we published a WIP right away. And the data model was represented in JSON schema, and it was straight RESTful interface. What came out in August of 2015 was something that was more OData-ish because of some influences inside the DMTF, and then the base models were out as well. In 2016, we extended everything that was a meet comp for IPMI 2.0 over IPMI over LAN 2.0 and extended it to really the majority of the system. That included BIOS, disk drives, memory storage, volumes. We were at that point really looking at storage that was either RAID or single disk drives. Nothing exotic, no SAN support, no NVMe support, it wasn't even around. So it was pretty simple stuff. And then models for Fabric came out then too, because for us, that Fabric model was pretty simple, and it didn't matter if your Fabric was SAS or Fiber Channel or Ethernet or at that time InfiniBand. To me, we tried to create the simplest Fabric model we could with the fewest constructs possible to make it easy to manage, and then grow it over time as features and functions as it matured. Well, one of the ways to make a standard successful is never give anyone a reason to say no. Well, that's not represented in the data model right now. Well, help us extend it. Well, what you have is wrong. Okay, tell me why and let's work through it. And so having those two approaches were pretty beneficial to extending this over time. The KCS interface, which was that BMC to host interface, how your operating system or hypervisor would talk to the BMC, it was a PIO interface, a byte at a time, and that's just not meaningful. And the industry as a whole had kind of figured out, every vendor had figured out a different way to do it, so we standardized on a host interface, and all that came out in 2016. Since then, we've worked on composability, we've worked on profiles. Profiles were a way to take a line item veto to the spec. In other words, or rather line item requirements. These properties are required. If you have a fan, it must be represented this way. If you have a volume, no, label's not optional. No, technology is not optional. And we built tools that can go in and then crawl through your implementation, figure out if you're compliant to the profile or not. And we've been working with, I know SNIA does that, but OCP is another standards body we work with too. Okay, what's a standard pizza box server look like? Management-wise, it's got to have CPUs, we've got to have metrics, we've got to have this, that, and the other. Give the customers what they want, let them define their own profiles, shop that to their vendors in their RFQs, and that was the thought behind profiles. Server-side eventing, we came out with one eventing model when Redfish first started. It was really a push model. After that, SSE was invented, and so we took advantage of that. Open API, we were waiting on them to come up with their 2.0 version because we didn't want to hit something in flight when we were back in 2016 and 2015 or 2017. So once they hit their 2.0 version and called it Open API, we were able to, because we had already mapped it to not only CSDL, which is WMI, but also JSON schema, and had been publishing those two formats. It was easy just to create a build process that automatically generated the Open API docs. Remember what I was saying, separation of protocol from the data model. So because that data model was separated, you can really define it in any language you want. And any mapping you want, which you'll see why that was beneficial in a second as well. We added telemetry. Before that, we had metrics, but no service to serve them up. And what does a metric report look like? We added jobs. We always had tasks, because you never knew if something would be long running or not. But to actually have the ability to schedule a job of multiple operations at a given time, or a window, reboot the server, that kind of thing. So we're kind of moving up the stack in features and functions at this point. So that went in scheduling. We did our next round of composability. I always call it little c, middle C, and big C composability. The first one was very resource specific. You had to have the exact list before you created your machine. That could have been a VM, it could have been a, something that's in a partition. What you were creating kind of mattered, but we didn't have a way to say, give me some wiggle room. I need at least 20 megabytes of this, and I need at least, 20 gigabytes of storage or whatever for my image, The ability to come up with a targeted compose engine and create a computer system or a set of disk drives or whatever, a resource block. That was what Composability 2 was. We extended the messages, and then we got into certificates. And we realized also that our sensor model for the 1.0 wasn't as relevant anymore as we wanted. We initially did the power and thermal model straight off a chassis and in big arrays. And it was real easy for the BMC, but it was hard to consume if you just wanted, I'm only caring about the temperature at this thing right now because that's the one that's going bad or critical. It became very hard to do that. And so we started re-architecting some of that at this point. In 2019, we did a complete spec cleanup. The original spec was written in 2014 and then was rewritten in 2015, and a bunch of hands touched it with different styles. And so there was stuff scattered all over. So we didn't intentionally change anything. We just made it a lot more readable and clean. So it looked different, but it wasn't supposed to read different. That's also when we introduced aggregation and then Ethernet-based fabrics. eBGP was out there. It had become a lot more accepted in the industry. And there were folks looking at using Redfish to manage the fabric, particularly, in a HPC or server type domain. They wanted to manage that Ethernet-based fabric. And so we added address pools to the model. In 2020, we worked with both Gen Z and SNIA on the Gen Z model and NVMe over fabrics, and we finalized that Power and Thermal 2.0 model. DSIM is data center infrastructure management. That starts getting the other side of the power cable from your server or storage when you start going out to the UPS and the cracked units and both cooling on the other side of the wire, all of the power distribution units and all of the rest. And so we were working with industry partners on that. In 2021, SmartNICs had gotten to the point where they were prevalent, but everybody was different, and there were a bunch of folks trying to manage them out of band as well as through their own interfaces. So we came up with a model for that, as well as doing licensing. Turns out all of us had been doing licensing for a decade or more. It was all different, and customers started to want a single method of doing that, even though the license, what it covers itself, was different. Representing the license was something we worked on common as well. This year, we've done a lot in the security area, exposing component integrity, security policy, various registry updates, and tons of tweaks for CXL. And a CXL work in progress is out there, and we've been working with CXL to try and figure out how to manage and represent that in the Fabrics model. If you've never seen Redfish before, this is kind of the base unit. Everything gets a stand box off of the root. So you'll see that thing on the left there that's a service root, and there's a bunch of overhead kind of stuff in there, tasks, sessions, accounts, eventing, registries, schema, storage. So you can go see your, what kind of schemas this local implementation supports if it's not the ones off of the web. And then you've got a collection of systems, a collection of chassis, and a collection of management. Because your management is typically the thing that's, kind of outside the server watching things, whether it's at the enclosure level or the BMC or an aggregator or a resource manager. There's ways of representing those kind of things. Then you've got the collection of sheet metal or logical chassis. And so you can have chassis inside of chassis inside of chassis. You can have a blade inside an enclosure, inside of a rack, inside of a data center. And that's kind of defines your power and thermal envelope. All your electrical signals are very chassis oriented. It's tough to do software defined electrical, although I know they do it now. So that was where we hung those parts of the model. And so that's that physical sheet metal kind of view, and then the system view is the data plane kind of view. Look, I've got a system, and there's the things it can see under its data plane, the processors, the memory, the storage, the NICs, those kind of things that it can access on the data plane. So if you want to think about it, servers is the data, systems is the data plane view, chassis is sheet metal view, and managers is the management plane view of it. So noodling down on the storage view real quick, the Redfish view is really a representation of a storage subsystem, right? And the idea we had initially was, look, I've got a storage subsystem and it has one or more controllers with one or more drives and one or more volumes, and that's kind of it. We're trying to keep it simple. And so drive, volume, and controller are the three initial entities that we created. And drive was, hopefully, so storage was a representation of the system, and everything is under a storage thing. So I've got a collection of storage, just like I had a collection of systems or anything else. And then it has those sets of volumes, drives, and storage controllers. And so the drive, that's the media. It says physical media, but that's kind of becoming more and more interesting to talk about. But the whole part there, where's my part number? Where's my serial number? Where's the thing I could potentially assign more than one volume to? That was or one or more volumes to. That was the whole concept of drive. Volume was a logical construct that we've expected, some management thing was going to exposed to the OS or hypervisor, and that was the initial thought there, and so that has all the volumes and labels and all that kind of stuff. And then controller was, originally we were thinking kind of one-to-one for most controllers except for RAID, because if you look at, 7 years ago, you really did have a storage controller talking to a bunch of drives representing volumes. It used to be an array inside of storage, and when NVMe came along, we figured out, we need to break it out as its own object. It didn't work as, and so that was, actually, we just took the data definition and made it its own object. So you see that is deprecated as an array inside the current versions. The way this looks is a little bit like that. Storage can be at the root level, but in Redfish, we kind of look at a storage subsystem inside of a computer system, and that's our perspective. Obviously, SNIA is not that way, and it is allowed to be off at the root. So you've got a storage reference over there, and it's got one or more volumes on it that point to one or more drives. It can be one-to-one, and then controllers are broken out separately. And then you can figure out which controller is associated with which volume, and the rest, it's just if I drew all the lines on here, it gets too busy to read. Note that volumes are in collection under the storage resource, and drives are arrays. And if you don't have a chassis, you can hang the drive off of the storage subsystem. But if you do have a chassis, you're better off using those dotted lines instead and saying, hey, these drives are in this chassis and they're being assigned to one or more volumes. And then, of course, controllers can either be an object in storage or their own object, like for NVMe. We're kind of steering more towards making their own object no matter what. And that is to help the clients out there so that it doesn't matter if they're looking at an NVMe drive or any other drive, they can use the same set of logic. What this shows real well is the storage plane. It doesn't show the connectivity plane, and that's where the fabric model comes in. We spent a lot of time working on the fabric model for InfiniBand and Ethernet, and when NVMe came along, we did some rationalization and added a few objects that we were already considering in order to show NVMe. So the original objects were the fabric object. In this case, you see an Ethernet there, right kind of in the middle. And the initial thought was, look, I got a bunch of switches and a bunch of endpoints and a bunch of zones. In other words, I've got these things that connect everything together, my switches, and the switches have ports. I've got a bunch of endpoints. Think of the endpoint as like the IP address. It's not the actual port. It can be associated with one or more ports, but really I've got these bunch of IP addresses that are allowed to talk to each other, and that was a zone. Maybe it's a subnet, maybe it's not. It depends on your construct. If it's Ethernet, yeah. If it's something like CXL or Gen Z, no, it really represents the routes. Routing tables is what it really is. And so the thought was, look, some guy at a console is just dragging endpoints into zones, and that's what allowed to talk to each other. But I need to know if everything's connected, so I looked at my switches and my ports, and we already have NICs, and the rest are already represented, so they have ports. And so my ports can go to ports, and I know which endpoints are allowed to talk to which ports. we added two concepts in order to support NVMe. One was address pools, and that started out as eBGP kind of stuff. It's how do I know which endpoint gets which IP address, gets its addresses assigned to which, and that's going to help with subnetting. So when an endpoint comes up, it gets its address associated through an address pool. And then there was this thing called connections that we invented because we realized, man, zones is great in a very simple world, but gets very messy when you start having multiple zones and it gets too big. And I want to start adding endpoints to zones. It started to turn into this really hard patch model. So instead, we created connections, and it turned out that worked really well for NVMe, and you'll see that later as well with whoever's presenting on NVMe. So the connection really is now which endpoints are allowed to communicate, and it carries the read and write capability on it, which you can't really show that with zones, which is zone. This is just a bag of things that are allowed to talk to each other. If I want to instead really indicate, no, this is a collection of endpoints, since we added endpoint groups, this collection of endpoints are allowed only to be initiators, and this is only targets. And so instead of my connection doing individual endpoints, it could also associate to an endpoint group. And that becomes much easier to manage. I'm just adding a new initiator to my cluster, throw that one endpoint in that group, and I don't have to do a bunch of IOs. It took, by coming up with this model, we took about 97 IOs down to 3. And so it ended up being a lot more scalable for not only NVMe, but HPC and other situations. So that's and most of this is available on YouTube's out there. So if you want to see it again, you get more detail there. I talked about SPDM. That's become more and more important. And so Redfish, we added a device security model that matches SPDM. So SPDM and TPM sessions are now represented by this thing called component integrity. And it's got the state of the SPDM session. Who's the initiator? Who's the target? Because if you have a security manager, you want this as a separate object somewhere. You want that person to have rights to it and not anybody else to be monitoring this level of access in the system. So we broke it out as its own object, and it can look at the signed measurements to ensure signed measurements are a way that the device signs its workload with an agreed upon previous certificate, so it's a whole public key, private key thing. And so you can validate whether those measurements are what you expect or not based on what it tells you and validating the signature. So it's not subject to man-in-the-middle attacks. And so we started exposing all of this stuff out through Redfish. So the component integrity object is available through Redfish. In fact, there's an action on it where you can say, sign my measurements. And from Redfish, you can get the BMC to go down to tell the device, sign the measurements, return them out. And so it doesn't matter if your security and measurement endpoint is in your BMC or if it's out somewhere on the Ethernet, all of this can work. And then you also need policies, right? What's my allow list for certificates? What if one of my CAs gets compromised? So you've got to have all of those TPM and SPDM policies, and those are now represented by this thing called security policy, and that's hanging off of the manager. So that's got your trusted and revoked certificates list, your policies on algorithms, your TLS policies for sessions. Those are all out there as well, and that's subordinate to the manager. There is a way to figure out which manager is representing the Redfish service, and that's in the root. You can find the UUID for it and a pointer. It's just take me to that manager. So I think 2 clicks and you're down to the security policy. Of course, if that particular user has access rights to talk to it. So how do you fill in all that storage stuff without creating a bunch of lockstep firmware dependencies between the management controller firmware and the storage firmware? A lot of the ASN.1 type of providers or PLDM, it actually has this data model in there where you got a bunch of sensors and monitoring and control attributes. And in order to make sense of any of that information, your BMC firmware has to understand at a very intimate level of detail all of that information coming from the controllers, be they PCIe or CXL. You're hand coding everything. And I found that unacceptable, especially as our business models were moving much more to the provider level. I work for HPE. We buy our disk drive driver for each OS from a manufacturer. We get our firmware from them. We get the WMI or Linux provider from them for manageability information. The one thing we weren't getting was the BMC system of firmware. Well, you could go to vendor X and get their proprietary interface and link in with your library inside of your BMC, and you had to do that for every vendor out there. Not only that, every vendor had multiple versions. So I could potentially be running around with 30 different mapping codes inside of my BMC, and I found this unacceptable. So got a group of folks together, and what we did was we created basically a broker inside of the BMC where, you know, and then took it to the DMTF to make it an industry standard. And that's what Redfish Device Enablement is. It's really a BMC level device provider. And it doesn't matter what device you're representing. It's completely generic. Remember how I told you it's important to separate the security, the protocol from the data model? Because we did that, we were able to define the data model not only in JSON but in binary and create these dictionaries that turned a, you know, property string into just a tuple. Here's my number, here's my length. And then, you know, what kind of value is it? So all of that was be able to be changed into binary data and represented by the individual devices out there. And so you know, us as HPE, we've made support for RDE required for every device that we support. And we've got, and you can go out on the DMTF website and find out which vendors are supporting RDE. And it's pretty much everybody well, at least we care about. So what that allows is that adapter to be self-contained and self-describing. It's got a dictionary in it. You plug it in, the BMC goes out there and queries it, figures out which dictionary it is, loads it. And so when a request comes into the BMC, it takes that JSON, uses that dictionary to translate it into binary, shoves it out to the device churns on it. Now it may be a big packet, you know, a K to 4K, but the device only cares about certain bytes and bits in there, you know, if you've coded it right. And you can go in there and figure it out and figure out, you know, what's your temperature, create a volume, whatever, and then generate a response that also matches a dictionary. The BMC gets that response back, churns it through the dictionary, and then shoves it out the wire in a JSON packet. So it's really lightweight. The code inside the BMC to do this is like 50 lines. It's not much work at all on the BMC's viewpoint. It's going to take a little cache to you know, take that dictionary, but it depends on the number of IOs, whether or not you cache which dictionary and the rest. So implementing it, you know, there were a bunch of people that were skeptical on the implementation of it, and once we were able to prove it's fairly lightweight, it was easily adopted. If you're selling it to your management chain, what this does is it decouples the development cycles from a device vendor and a systems integrator. You as a device vendor can make any changes you want, add any value you want, you create your own dictionary, and as soon as you drop it in that server, it just eats the data. It doesn't need to have any code change at all to represent it. And so where it hooks into the tree and all of that was part of the protocol to begin with. And so a device owns, it's part of the Redfish tree and everything under it. It can own multiple trees too, as you'll see in a minute. So by leveraging the PLDM architecture, a provider really can be self-contained, self-describing, and an existing BMC can pick up that code and use it as long as it speaks the right version of RDE. So we really did decouple the development cycles from the devices and the BMCs. So what's it all look like? Well, you know, it used to be fairly simple, and this is kind of an eye chart, but for an individual device, particularly a storage device, I've drawn a line around the information you get from RDE for every storage, let's call it an array controller out there. So you'll see component integrity at the top. That's my certificate collection. And also, because the BMC in this case is the SPDM requester, and the device is the responder. And so the requester has that component integrity information. But the device has the certs. Now, I may have gotten them through SPDM, but I also could get them through RDE. In this case, they're gotten through SPDM. The telemetry service is, well, the device knows what kind of telemetry it supports, so it's got the metric definition, as well as you look in there, you'll see some metrics scattered about. I think there's some metrics on the drive, and there's some metrics on the port. And so this particular one, that's what we've shown. But, you know, we didn't really draw the dotted lines to those individual metrics because it would have really gotten ugly in the case. But that's what they are, right? So there's more than one metric definition possible. The storage collection is in the BMC, but the individual storage instances are all owned by the storage device, as are the volume collections and the chassis, right? So the chassis in this case is its storage enclosure or its backplane, as well as the fabric. If this is a SAS backplane, it knows about its fabric. It knows about its switches, it knows about its ports, it knows who can talk to what, and all of the rest of it. So the BMC has no business being in that. It would just be an arbitrator anyway. And so all of that comes directly from the device. Now, the BMC does still have a chassis, in this case it's a rack mount where it controls the power subsystem. And for our systems, there's a battery backup for most of these storage controllers that go in. And so we do have the ability to associate an individual battery. In this case, is associated with a storage controller because that's the controller that we're backing up, and our RAID card in this case. Now you'll notice that line is dotted. There is a way to do non-top level object associations inside of RDE. It's not trivial, but there's a way to do it. We try and keep those few and far between. And PCI is done the same way. The BMC, if you're trying to debug information, you really need to know the PCIe information of who lives what and where. Not only what the system thinks, but what the device thinks, right? And so if those two aren't matching up, if your number of lanes or BDF or any of that stuff doesn't match up, in a debug situation, this information becomes critical. So in a very detailed, exhaustive kind of way, this ends up being the entire Redfish storage model. But it is pretty gory. And but RDE makes this easy because we've divided that line between the storage controller's knowledge domain and the system's knowledge domain, and make sure that they're separate and they're not overlapping. So last shameless plug, if you have any doubts of anything Redfish or the rest of it, you can always go out to redfish.dmtf.org. It's actually got an initial LinkedIn link page. So if you're an architect or manager, you click one link. If you're a developer, you click another link. What we found is everybody's doing deep bookmarks now. So when a new version of the schema comes out, you just go straight to the schema guide. We are changing the way the schema guide works a little bit. It used to be just informational. It didn't have any of the normative information in it. And the new version of it coming out with any day now in 2022.2 version of Redfish is going to have both the normative and informational part of that specification. So take a look for that. You can find mock-ups out there. It's similar to the Swordfish site with respect to both educational YouTube links and all of the rest. So in summary, Redfish, along with other DMTF work groups and DMTF alliance partners like SNIA, we're really working to develop and define and promulgate through the industry interoperable software-defined hybrid IT management for server, storage, networking, power, cooling, fabrics, all of IT infrastructure. Solving problems from security attestation for the device, so that's really paramount, but it's also paramount to represent that outside the box in a secure fashion, especially for those people whose job function it is to know that information and validate it. And then we're plumbing the mechanisms inside the box to be self-contained, self-describing, lowering development costs for everybody along the ecosystem, as well as enabling a zero trust model in the platform. With that, I think I'm at time. We've got about 10 minutes till the next session. Does anybody have any questions? Good morning. Hope that wasn't too big of a day to dump too fast for a Monday morning. Yeah.
How often do you guys update the code for Redfish?
So whenever anybody asks, right now we're on a 3 times a year, and that's kind of historical. We like to put the spec to bed right before Christmas so we can all take a nice holiday break. That one tends to come out in January and is the last release for the year. We tend to do the next one sometimes in April because it feels right. We used to do one in August, and so that one in April was kind of around our IDF, but now we're thinking of moving it closer, so it's closer to OCP, but OCP might be in March, but it's in October this year. So I think COVID kind of messed up some of our reason for the schedules. We've done 4, like when SNIA wanted to do their release in, I think it was September, October, we threw one out there real quick to make sure we'd pick up Swordfish. So we'll probably do a special release for CXL, although we're trying to get it in, the last release for this year. We've been working with the CXL on their model for over a year. So we finally gotten good feedback, and there's efforts over there helping us to get feedback on the model. So we're looking, my personal preference is to finalize the CXL data model, at least version 1.0. We can always add more later, but at least the 1.0 stuff, I want to see that by the end of the year. I don't know of a reason why we wouldn't, but who knows. So basically 3 times a year, April, August, December, and so they come out about a month after that because of IP review. But if anybody has a reason to do one in the interim, we're more than happy to do one. Any other questions?
Is there an official site to submit requests to?
Yeah, so if you go back to that developer hub, there's a couple ways you can get there. That bottom right thing is there's a Redfish user forum out there. And we go through that Redfish user forum data every week in the meeting and figure out what those responses should be. So, we really try and be responsive. And it's funny because we'll have people, we've developed all of this in GitHub, and it's been really great because, if a feature or function's ready, you merge it into the tree. If it's not, you keep it out. And so people generate issues. Well, now people from our own member companies are using the forum instead of the GitHub to enter issues. And that can be good, it can be bad. If it's something that's not ready to be talked about in public, it's bad. If it's better off being talked about in public, it's good. So, we try and manage that as best we can, but certainly we're responsive on both the issues and the internally and externally. Any other questions? Yep.
Are there places where we can find sample implementations of Redfish services? Is there an interop lab?
So is there an interop lab for Redfish? Yes, there is for Redfish Forum members. We co-located it with the SNIA interop lab. And so if you're a Redfish dues paying member, we've got, I think, 5 implementations in there, 5 different vendors' implementations in there. And it's open access for anybody, provided you're not doing competitive analysis. If you really are trying to do interoperability kind of things, yeah, that lab is open for members' use.
Is there a process to contribute machines to that Chrome lab?
There is a process to contribute machines to the process. If you're a member, talk to me. It's not hard. The hard part is finding out where to ship it to. But the co-chairs, talk to Mike and Jeff, Mike Ranieri of Dell and Jeff Otter of HPE, and they'll get you hooked up. You probably have to go through Robert as well, so I think he knows the shipping information. Because there's that, IP assignment and all that kind of stuff. But yeah, not a problem. Glad to have more. Any other questions? If not, thank you very much. I'll be around for the next couple of days, so if you see me hanging around, don't be shy about asking anything you can possibly think of. Thank you very much.